complete the table of values to graph p of x equals negative 2x plus 1 and q of x equals 2x minus 1. Then generate values for p times q of x equals p of x times q of x to graph their product function in the same coordinate plane. Use the polynomials for the factor functions to write a polynomial for the product function. Okay, so first it tells us here to go ahead and complete the table. So for p of x, let's just plug in all of these different values. So plugging in negative 1/2, then we get negative 2. So using this function up here, we get negative 2 times negative 1/2, which is positive 1, plus 1 is 2. And then plugging in 0, negative 2 times 0 is 0, plus 1 is 1, and so on. And then same for q of x, just going ahead and plugging in these values. 2 times negative 1/2 is negative 1, minus 1 is negative 2. 2 times 0 is 0, minus 1 is negative 1, and so on. And so then for the last column, then we can just multiply together the other two columns. So 2 times negative 2 is negative 4, 1 times negative 1 is negative 1, and so on, multiplying each of those columns. And so just a few things to note before we look at the graph of these. Note that when x is equal to 0, that's going to be the y-intercept. And so notice that p of x is 1, q of x is negative 1, and then those should multiply together to get the p of x times q of x. And 1 times negative 1 is negative 1. And that's how we came up with the table, but that should be true. And then also note the x-intercepts. So those are all the same at 1/2. So when you're multiplying p of x and q of x together, p of x times q of x should have the same x-intercepts as both of the functions that are being multiplied together. And so since both p of x and q of x have an x-intercept at 0, 1/2, then that means p of x times q of x has two intercepts at 0, 1/2. So I've gone ahead and just plotted these points and these graphs. Let's pull that up. And so having graphed those, again, it just shows our x-intercepts here and our y-intercepts. And then let's go ahead and multiply together also p times q of x to get the actual product function. So substituting in for p of x, we can just plug in the negative 2x plus 1 and 2x minus 1. And then we can distribute and multiply these together. So negative 2x times 2x is negative 4x squared. Negative 2x times negative 1 is positive 2x. 1 times 2x is positive 2x. And 1 times negative 1 is negative 1. So in simplifying that, we get negative 4x squared. Positive 2x plus 2x is positive 4x minus 1. And so there is our polynomial. Now we can go ahead and summarize our answer. The graphs of all three functions intersect at 1/2, 0, which means that p times q of x has two identical x-intercepts. The y-intercept of p of x is 0, 1, and of q of x is 0, negative 1, which is seen as b in their equations. And so the y-coordinate of the y-intercept of p times q of x is the product of the y-coordinates of the y-intercepts of the factors. The product of p of x times q of x produces the polynomial function p times q of x equals negative 2x plus 1 times 2x minus 1 equals negative 4x squared plus 4x minus 1.